So friends, in this lecture we are going to teach you that GSM, that basics of GSM and the GSM system actually. So the full form for GSM is, as you already know, that global system for mobile interconnection. What is the actual meaning of actually global here? Generally we think that global means the thing which is international level standards. It's okay, but actually in the terms of engineering and in the terms of science and technology, globally slightly different what we think. So basically I'm going to start from the very basics of GSM, and that is analog communication. As we have know that GSM is exactly similar to the wireless communication. So first in this chapter or in this topic we are going to discuss with the basics of analog communication, because all of us know that in analog communication what happens, three entities are very important. The first one thing is sender and one is the receiver, and it between medium is the media, any media. Let us here is a air or free space we call. So suppose sender is sending any massive signal. Let us zoom here in this GSM, and that it is an audio signal or the voice signal. So for sending any kind of signal, it is necessary that we have to choose the frequency, particular at which frequency we are going to send the signal into the air. So suppose let us assume that we are sending any signal, frequency is equal to 200 kilohertz. So now this signal or now this our message is in the air. Now it is responsibility of receiver how to detect this signal and then how it is going to decode that particular signal. So it is the responsibility of receiver. See, there are many signals, there are a lot of different kind of frequency signal is present at the receiver side. But how is it able to detect this signal? I mean demodulate and encode and decode the message which is inside this. So suppose there is a lot of signal from 1 kilohertz to 1 gigahertz signal is present inside. Suppose there is one radio system is there. So basically it depends on the frequency or the filter design. Suppose if you design a filter, let us assume that is a filter that we are design, so that exactly that cutoff frequency, or we call it a center frequency, is matched with this filter, is matched with this center frequency, then we can easily recover this signal. Otherwise it will lost here. So it is very necessary that our receiver or our any receiver is able to detect the signal based on the frequency. So that's why before going to start GSM subject, our main subject, it is necessary to understand the frequency operation of GSM. So we were talking about frequency. So let us try to understand with the help of FM signals. Okay, here we can see that here is a one radio receiver is there, and let us examine any city. Let us example in Delhi there are 4 FM signal is there, which is called Radio Mirchi, Radio 1, with Bharti and Red FM. So each are transmitting with a different frequency. I mean its center frequency is 98.3, Radio 1 95.3, with Bharti 102.9 and Red FM 94.7. So all are the signals are present at the same time at the receiver. All are the signals. But can we not able to listen all the 4 signals? So that's why if we want to listen at the time Radio Mirchi, we just rotate the knob, and when it cut off frequency or when it is cut off frequency or center frequency when matched to its 98.3, then you can hear easily that 98.3 Radio Mirchi. So for that purpose, suppose there is right now there is a center frequency is here. Now we are listening 98.3 Radio Mirchi signal. What happen after some time if you want to listen Red FM? So if you rotate the knob, then inside that radio receiver there is a facility that if you rotate the knob, then its certain frequency will change according to your rotation. So suppose after some time what happened, this will go here. So now you are able to listen Red FM. We cannot hear radio Mirchi and radio FM at the same time, because now our cutoff frequency or now our central frequency is moved from radio Mirchi to 94.3, so radio FM. So that's why it is very necessary before going to depth into the details of GSM to understand the frequency operation. Once we know the frequency, how the frequency is divided among the different operator. See, in India there are many operator, many telecom operator. So how the frequency band is divided among the different operators. So it is very necessary to understand. So see here, the entire frequency spectrum is divided into basically three major categories. One is the radio frequency, one is the optical frequency in which infrareds like that come, and one is very high frequency, as you have already heard about that, X-ray and gamma ray, all these things. So while we are talking about GSM, so it comes under the radio frequency. See, in the radio frequency, it starts from very low frequency, I mean in 30 Hz to 300 Hz. So it's the first classification is very low frequency, short frequency, FM, and then for cellular frequency. So basically what happened, the first reason is for naval operation. In military, naval operation is used for 300 to 300 Hz, and one for short radio operation, and one for 88 to 108. So basically what happened, this frequency is reserved. This frequency is reserved, 88 to 108 is reserved. Suppose if you have money, if you want to build up or set up your own FM radio station, then what happened, you build up all these requirements, and if you want to transmit the signal, your signal should be in between only 88 to 108. You cannot go and transmit the signal wherever you want, because see, the frequency spectrum is the government property. You cannot go and transmit any signal at whatever you want at which frequency, because see what happened, let us, I am giving a very basic example. So to understand this, let us assume there is a we are talking about some area like in defense area. What happened, there is two antennas there, okay, one is antenna for receiving and one antenna is for sending. Suppose some sensitive information is sent through from antenna 1 to 2, okay, in remote area, in military area, okay, and nearby your radio station is also there. So what's happened, you are sending the information at the same frequency at which the military, I mean that antenna is sending the, what happened, the receiving antenna will receive two signals. From the signal is desired antenna and unwanted antenna. So at this point of what happened, it will create a interference like phenomena. So that's why it immediately inform the India government or whatever with the, so that I am not receiving the proper information. That's why it will detect that from which kind of information is coming. So that's why your immediately government will take the action and you will get punished. So that's why I was discussing that if 88 to 108 frequency is reserved for FM operation, then at the same situation is there that 892 to 915 is reserved for GSM operation. I mean, suppose there are cellular company, there are telecom operator, okay, suppose that telecom operator is want to send any kind of signal, the frequency must be used by this telecom operator in between 892 to 915 for sending operation. I will tell you later in the receiving operation, but before that is that 890 to 915 is fixed for entire country. If you go anywhere, 890 to 9150 is reserved. If you want to build, if you want to do any operation like FM transmission, then you have to use this band. But if you want to send or receive any kind of GSM operation or any kind of cellular call, then we have to use that 890 to 915 megahertz. So it is fixed for GSM operation. This frequency is fixed. Suppose if I want to start a telecom company, then we have to request the government that I want to build up a telecom company, so please give me some amount of band in between 890 to 915 for sending operation. I will tell you for receiving operation, but for sending operation 890 to 915 Hz is fixed. So that is, in the earlier I was told that why is it so that global means what happened, if you go UK, US or any country, that 890 to 915 is fixed. That's why, because in our mobile there is an oscillator. or there is a frequency generator which generate the frequency in between 890 to 915. Suppose if you buy a cell phone in India, and if you go to the US or some other country, okay, there is a cellular operation is running between, suppose some different let us assume some 90 to 90 megahertz, 90 to 190 megahertz. So you are not able to receive the signal, because here we are sending 892, our frequency range is 892 to 915. Your mobile will not work. Why is it not work? Because in every mobile there is a frequency generator. I mean frequency oscillator is used for generating frequency. So your mobile is not able to even generate 890 to 915. Then how is it able to send or transmit? So that's why global means you go any country in this world, okay, the 892 9115 is reserved for sending the information through GSM. So that's why that frequency band is the property of India government. Some earlier frequency is fixed for military operation, some is for FM, some is for other, and some for satellite communication, some for radio transmission. So it's the government that they will decide which frequency is used for which kind of operation. See, but it is not necessary. Suppose if India uses 90 megahertz to 190 megahertz for defense operation or for military, it is not necessary that that US or UK or some other country will use also 90 to 190 megahertz for military operation. It is independently. It can use later frequency also. But for GSM operation, every country must have reserved for this band of frequency for GSM with the GSM frequency. So that's why we are telling that for sending operation the frequency is fixed for 890 to 915 Hz. So total 25 megahertz is for sending operation, and at the same time for receiving operation. See, why is it so that for sending there is a alternate band and for receiving there is another band? See, in mobile what happened, we can speak simultaneously, okay, so without causing any kind of interference. Suppose sometime what happened, you talk to your friend and immediately you are talking and your friend is talking simultaneously, okay. So suppose if it is not for different frequency, then it may be also that interference phenomena occur and voice will be lost. So that's why for sending your mobile, the oscillator or the frequency generator in mobile is uses for this frequency. Suppose at the same time, suppose you let us assume that there is only one for sending. So what happens that if the oscillator will not tune for this frequency, so the two signal is sending. Suppose you are sending also some letter this frequency, and the receiver, okay, your receiver is also suppose receive at the same frequency, okay, then maybe it may also happen that voice may be lost. So that's why for sending operation it is used for another frequency, and for receiving operation it is used other frequency. So that's why you are able to listen some kind what happen when you are talking very loudly and you are quarreling on your mobile phone, okay, you are also telling and you are also receiving the voice signal at the same time with the two different frequency. So that's why without causing any kind of interference, it is designed such a way that for sending there is another frequency used, and for receiving another frequency used. That's why it's called uplink frequency, and this is called downlink frequency. So the point is come with that 25 megahertz, 890 to 9, the difference between is 25 megahertz, and for receiving operation it is also 960 minus 935, 20 megahertz. So 20 megahertz is for sending, and 25 megahertz is for receiving. So now the question is that if the 25 megahertz frequency is used for receiving and it is sending and it is for receiving, how the actual length of channel is this. So I'm going to in few slides, after little later I'm telling you how. So now I'm telling that for sending purpose 890 to 9115 megahertz are reserved. So it is divided the channel length. For each channel, this is the band in which there are 124 channel, 124 different frequency can be used. In between 25 megahertz, so total length is 25 megahertz. In between because each channel length is, or we can say that each message signal has to bandwidth of 200 kilohertz. So we have total band length of 25 megahertz, and each message, I mean we can say that each channel length is 200 kilohertz. So if you divide the 25 megahertz divided by 200 kilohertz, so we will get 125 channel. So there are a 124 channel is available, or we can say 124 different frequency in the range of 25 megahertz is available for sending the data. At the same time, you can think about that 935 to 960, there are still a 124 channel to receive the operation. So, and again, suppose let us assume that there is a channel number 1. So suppose there is a receiver which is using the first frequency, let us assume 890 megahertz. Another is 890 plus 200 kilohertz. So anyway, you can add up 890 plus 400, 890 plus 600. So different frequency you can use for different sending operation. So total number of frequencies available is called 190. So first is 890, second is 890. If you add up then it will be the second frequency. So total 124 different frequencies available for sending operation. Similar 124 is available for receiving operation. Now what happened? The one channel is also divided in 8 time length. That's you have already might study in the TDM, time division multiplex access. That the frequency is, the frequency is only a single frequency is divided into time as rate. 8 time slot. 8 time slot. Suppose let us here. Suppose if it is 890, 1, 2, 3, 4, 5. Let us assume. So channel. So for frequency 890 megahertz, there is a 8 user can occupy to use this frequency 890 hertz. Okay, so that's why we are, suppose me and my one friend, okay, receiving the information which is 890 megahertz also, but it is not possible that same information can I also receive and he will also receive. No, it's not like that, because see, it is also divided into the time frame. Suppose what happened, immediately if someone call you, then it will go to the first time it go to your friend, then immediately it will go to the, the frequency is same, 890 megahertz is the same, okay, but it will in the time slot number 2 you will receive the information. So again it will go to the so it may be third is for some other user, fourth for other user. So likewise that. So one frequency there is a 8 user can accommodate with the same frequency, but the switching time is very less. That's why we do not feel any kinds of time delay. Okay, because it is very fast operation. So you are not thinking that we are using the same frequency, but the same frequency is shared by the 8 other user with time difference. So it's not like that. It is not. You will feel that after 8 millisecond or after some kind of nanosecond you are receiving the operation, because the same frequency is switched between 8 users.